we have a problem, and people, I handed out a set of problems from the third edition of the book, and that comes out kind of neat. You can still see many of those problems in the 14th edition, okay? I was thinking I learned out of the second edition, I'm pretty sure I did, but the third edition was published the year before I started college. I took it my freshman year. But I think we're still using the second edition. I distinctly remember we were in the second edition. That was, over 50 years ago. Anyhow, our library had a third edition. They discarded it. I picked it up, and I made a copy of the problem set. I don't think I'm violating copyright because we are using the 14th edition of the same textbook, the same publisher. I think it's the same publisher. Okay. Problem is, you go from 0 to 1,000 miles an hour in 1.8 seconds, assuming uniform acceleration. How many G's is that? Well, first of all, what's a G? Well, a G is the acceleration of gravity, which is 9.8 meters per second squared, approximately. Pretty good approximation. And we round that off to 10 centimeters per second squared for a lot of work because it's only off by 2%. And if we're careful, we can make 2% adjustments when we need to. Of course, that means if we're using t squared, we've got to make a 4% adjustment or something. But we deal with that idea later. Okay, so that, in my usual careless fashion, I said 1,000 miles an hour equals, and then I immediately went to the what a mile per hour is. It's a mile per hour is a mile, which is 5,280 feet, divided by an hour, which is 3,600 seconds. And I got hung up on this, and I never wrote my 1,000 down. I got down here and got a ridiculous answer. So what in the world? Okay, how could I be off by that many orders of magnitude? And oh yeah, I didn't write the 1,000. So the 1,000's written in here pretty small. But I've kind of got it on every calculation, and you can follow it easily enough. It's 1,000 times this over this. Now, a foot is 12 inches, so I replace my foot by 12 inches. Okay? And then an inch is 2.54 centimeters, and you should know that. Okay? It's your basic conversion, the fundamental conversion between metric and the old British system. Okay, so I replace inches by 2.54 centimeters. My denominator is still in seconds because we're going to want meters per second to get the acceleration in meters per second squared. Okay, and a centimeter is 0.01 meter. That's written kind of badly there, but that's 0.01 meter. So we multiply all this out, and then we divide by 3,600. Now my estimate here, that's about 60,000. We're a little low with that. 2.5 times 60,000, 150,000. We're still a little bit low. And then multiply that by 0.01, and we get 1,500. That's why I got into problems, because 1,500 meters over 30, it's less than a meter per second. I know 1,000 miles an hour is a lot faster than a meter per second. That's because I forgot to write my 1,000, but there it is. So that becomes 1.5 million. Meters over 3,600 seconds, and now it makes a little more sense. Okay, well, then I estimated that to be about 400 meters per second, and I knew that wasn't completely accurate, probably a little bit low, because I was basing it on numbers here that were a little bit low, and didn't work. So, somebody did it with a calculator, about 440, so that's about 10% low. But for ballpark, that's what we use. Okay? Then we proceeded to figure out the acceleration going from 0 to 400 meters per second in 1.8 seconds. And then we compared that with the acceleration of gravity to get the G's, and we'll finish that up in the next video.